What is the data and why is it useful? Shrinking and swelling of the ground, often reported as subsidence, is already one of the most damaging geohazards in Britain, costing the economy an estimated £3 billion over the past decade. There are some 2.8 million homes in the UK at potential risk from shrink-swell subsidence, and this number could increase to 8.5 million homes by 2070 due to projected changes in climate. However, if you are aware and forewarned about this hazard, many problems can be avoided. To help to identify and prepare, BGS has developed their GeoClimate data product. GeoClimate Clay Shrink-Swell identifies areas of potential change in clay shrink-swell susceptibility as a result of the impacts of climate change across Great Britain, which areas could get worse and which areas might experience new issues. It is based on science and several years of research. It considers the change in climate, changes in groundwater content, the type of geology and the geotechnical properties, and specifically how the ground reacts to changes in water content. What does the data look like? Two versions of GeoClimate are available. The open dataset is free on the BGS GeoIndex and designed as an overview for national scale use. It is based on the premium product and generalized, taking the worst case rating for each 2 km grid cell. The premium dataset is a licensed higher resolution and more detailed dataset. It is designed to provide input into regional and local risk and mitigation assessments. Wetter and dry climate scenarios are also provided, representing the best case and worst case scenarios. As an example, we will use the data to look at the potential impact around Grange Barn near Colchester. This Grade 2 listed medieval barn currently lies on deposits that are susceptible to shrinking and swelling. GeoClimate shows that this susceptibility will increase in future years. In fact, this barn has already undergone various modifications and structural repairs over the years. Looking to the future, we can see that in the 2030s scenarios, under average conditions, the potential for a change in the ground movement is likely. This moves to highly likely by the 2070s. If we look at the worst case scenario for the 2070s, the area could be extremely likely to experience changing conditions. Careful consideration needs to be given to the foundation type and depth to ensure that it is suitable to withstand potential increases in ground movement. Mitigation and adaptation are key to being prepared for the future. As well as properties, transport networks, infrastructure and utilities are equally vulnerable to potential subsidence. These issues could impact on maintenance, services and supply. Should you want to find out more about this dataset, including its limitations, then please consult the product user guide. Visit our product web pages or contact BGS data inquiries at digitaldata@bgs.ac.uk.